In this video, I'll take you through the basics of Tinkercad circuits, a breadboard simulation software that you'll use throughout this lesson. Your teacher will have specific instructions for creating an account and logging in. Once logged in, select Create, and then Circuit. Tinkercad automatically names your new circuit, but you can change this name to something that you will be able to access later. Most of the circuits throughout this lesson will require a power supply, breadboard, and some basic electrical components, as well as a multimeter. You can find those items all to the right by scrolling through this list. You can also manually type them into the search field. So let's start by adding a power supply. If I type the word power in the drop-down, power supply automatically comes up, and I can see the item right here. I can click and drag the item onto my workspace, and notice I can change the name if I want, and I can change the voltage. So we'll make this a 4.5 volt power supply. Next, let's add a breadboard. So I can clear my search by clicking that X, and I can see actually the breadboard is right here. So I'm just going to click and drag it over into my workspace. Now this breadboard functions like a real breadboard in that individual rows here are electrically connected up until you get to the gap in the board here. So this is not connected to this side, but all of these holes are connected. Similarly, the positive and negative rails of the breadboard are fully connected here. So to connect the power supply to the breadboard, I can click on the positive terminal of the power supply, brings a wire over, and I can click to a hole on the positive rail of my breadboard. Now I have a wire so that this rail is all connected to the positive terminal of my power supply. I can clean this up a little bit by double-clicking the wire, which adds a little bend, and I can kind of bring that over so that it's both horizontal and vertical. Just keeps things clean. Typical convention is for your positive wire to be red, so I can change the color up here in this drop-down menu, or by clicking the different numbers on my keyboard, 1 for black, 2 for red, so on and so forth. So I want this to be red, so I'll click 2. And I'll do the same thing to connect a wire to the negative rail of my breadboard, and we'll make this wire 1 to follow our standard convention. All right, now let's make a simple circuit with just an LED and a resistor. I see them right up here, so I can click and drag the LED. You'll notice an LED is a polar device, which means it has a cathode and an anode, so you need to pay attention to those. This would be the longer leg of my LED, which gets connected to the positive side of my breadboard. So I'll place this LED on my breadboard, and I'll connect a wire from my positive rail to my anode. So I can just click and then click to there. And I'm going to change this color to green. Right now I'll add a resistor, click and drag. Notice that resistor is shown in the vertical orientation. I want to change that. I want to rotate it. I can do that up here or by clicking R on my keyboard, and it rotates it. Now, a resistor is a non-polar device, which means it doesn't matter in which direction the current goes through it. So I will move that onto my circuit right there, so it's electrically connected there. And I'm going to change the value of that resistor to 220 ohms. Right now it's set for kilo ohms, so I need to change that unit. And now all that's left to do is to connect this side of my resistor to ground. And now we have a complete circuit for current to flow. I'm going to check that really quick before I start a simulation. So I go from positive through my the LED in the correct orientation there, through my resistor, back down to ground. That should work. So I'm going to start simulation, and it works. So my LED is illuminated. That looks great. Next, I'll show you how to use multimeters so that you can measure both the current through a circuit as well as the voltage across a circuit element. So let's start by placing a multimeter on our board here, on our workspace, to measure the current that's going through this circuit. So to do this, I need to wire my multimeter in series with this circuit. And first, we want to make sure that we have the mode selected correctly for our multimeter. We want to measure the amperage. So I'm just going to delete this wire and instead go from my power supply through the multimeter. And here again, I'm going to change these wires to red. I hit Shift. Well, I had one of them selected. I can hold Shift on the keyboard and click the other one. Now both of them are selected, and I'm going to hit 2 on my keyboard so that they both turn red. And now let's just put some bends in here so it's clean. And that looks pretty good. So I can go ahead and test this. Start simulation, and my multimeter is correctly reading the current going through this circuit, which looks great. Let's add another multimeter to measure the voltage across this resistor. So for this one, I want to make sure that my mode is selected in voltage here. And I'm going to connect some wires across my resistor. And that looks okay. Again, I can clean this up if desired. Okay. Now it looks like I have my wires connected properly to my voltmeter, and it should give me the voltage across that resistor. So I'll hit Start Simulation. And that looks good. I'm showing 2.5 volts across this resistor. So this concludes some of the basics of using Tinkercad model circuits, and it should provide a good foundation for all the modeling activities within this lesson.